Every runner wants the ultimate trainer. So imagine this, a trainer so high-spec that it behaves like a living organism.
It just keeps growing. People would like that.
That future may not be so far away. Meet Artemis, a Persian blue cat, and his owner, researcher Dr. Martin Hanzik. Experimenting on the boundaries between the living and the non-living, his findings could revolutionize our relationship with materials. Passionately committed to preserving the natural and the built environment, he's working with a technology called protocells, artificial materials that can be made to respond like living organisms. When he's not walking in the Alps, Martin works in the beautiful historic town of Trento in northern Italy. Much as he loves them, he knows that every building here, like any structure man has ever built, is slowly deteriorating.
When we look around a city like Trento, we can see that the building materials were set there and they are slowly crumbling into their environment. And this is normal. And actually it adds to some of the romantic beauty of these kinds of ancient places. We can see various types of architecture and various types of materials that were used to build this town over the centuries. And they typically are very hard, static, unresponsive materials that one could shape to make, for example, the paving stones in the streets.
Traditional inert materials like marble or even iron and brick can't adapt to their environment. Left unprotected, they would corrode and eventually perish. To find new materials that resist the ravages of time, Martin is working with these. These unpromising-looking blobs of red oil are called protocells. And here at the Centre for Integrative Biology, they're the focus of Martin's groundbreaking work.
So in the laboratory, we do research about artificial life. So we're trying to make non-living chemical systems that behave like living systems. First, I will create the environment for the experiment, which is basically soapy water, nothing toxic. Normally an oil droplet, when you place it in water, doesn't do anything. It'll just sit there.
But Martin adds a simple chemical agent to the red oil, which makes it behave in a very different way.
So now I'll just introduce a small population of self-moving droplets to the system.
And the droplet immediately starts to react. It's changing shape, and now it's starting to move through this little chemical environment that we've made and exploring the different parts of it.
You can see there quite a bit still moving, and it looks like there's a bit of sort of pairing up and dancing in one corner here.
To compare this behaviour with normal oil, Martin then adds droplets of blue oil that aren't treated with the chemical agent.
And we can see by putting in this control droplet that it doesn't move. It's not interacting with its environment in any way. And that's how we can distinguish between the two systems.
Martin's vision is to apply the principle of these reactive materials to our homes and cities.
We are thinking ahead to new kinds of materials that one might be able to use in the built environment to make buildings, to make homes that are more responsive and more integrated into the environment.
But what if these new materials could do what the old materials cannot? What if they could be like living systems trying to maintain and preserve themselves? They would need to move to change their environment, just as the oil drop protocell does.
One of the future visions for making new materials with lifelike properties is that you would have a structure that is self-repairing, perhaps self-growing, self-reproducing even.
It may sound like sci-fi, but Martin's vision has already inspired London-born designer Shamiz Aden.
I'm a speculative designer and I was very much interested in looking at the future of footwear design and how emerging technologies could impact the way we run in the future.
Transforms resources.
I actually saw a TED talk on Dr. Martin Hanzig, and I was really excited by his body of research that he was doing on protocell technology. And just by chance, I just emailed him out and just said, would you be interested in collaborating with me as a student, interested in new materials? And we started working together on developing this concept of this pair of running trainers. They will adapt to the individuals as they're running. They'll be more in tune with the individual's foot and reconfigure and adapt depending on the pressure and the time.
The Amoeba shoe is still only a concept, but the potential of protocell technology is real and present.